Butter has been part of human diets for millennia, spanning continents and cultures. Historically churned by hand in small batches, it's prized for its luxurious taste and its ability to enhance both sweet and savory dishes. Of course, if butter gets any more luxurious, we might need a red carpet just to spread it on toast. Over time, factories emerged to meet growing global demand, processing enormous volumes of cream into consistent quality butter. Today, these factories employ a mix of food science, dairy expertise, and high-tech machinery to maintain flavor, texture, and safety standards. In some rural areas, families still use traditional churns to make butter at home for special occasions. They might serve it during village festivals, demonstrating how this age-old craft endures despite modern industrial methods. The taste differences can be surprisingly pronounced, reflecting local pasture conditions and artisanal techniques. Stick around, because in the next few minutes, we're peeling back the curtain on everything from the dairy farm journey to high-tech factory magic, and even the secret steps that give butter its legendary flavor. By the end of this video, you'll know exactly how quality butter is made and how to spot the best of the best for your kitchen. Plus, I've got a few insider tips that could take your cooking to a whole new level. If you're ready to become a butter connoisseur, hit that subscribe button now. And let's dive right in. All butter starts with milk, specifically the cream portion of milk. Dairy farms supply fresh milk from cows, typically transported in refrigerated tanker trucks to processing plants. Farmers and factories adhere to rigorous testing and sanitation protocols to ensure the milk is free of harmful bacteria, off flavors, or other issues that could compromise butter's taste or shelf life. Once it arrives, the milk is pumped into storage silos. Laboratory technicians perform quality checks, measuring fat content, protein levels, and overall freshness. Milk that passes inspection proceeds to the next phase, separating cream from the rest of the milk. Imagine a large dairy farm in Wisconsin or the Netherlands where cows graze on lush, rolling fields. Twice a day, they are milked using automated milking systems. Each milking session's output is carefully chilled, tested on-site for bacterial count, and then quickly transferred to refrigerated trucks. This ensures the milk's freshness when it finally reaches the butter factory. Most modern butter factories use a centrifugal separator, a high-speed spinning machine that exploits density differences between fat and water-based milk components. As the milk is spun at thousands of revolutions per minute, heavier components, like skim milk, are pulled outward, while lighter fat particles move toward the center, emerging as cream. The skim milk is set aside for other dairy products, such as cheese, yogurt, or powdered milk, while the cream heads toward pasteurization. This separation process allows factories to precisely control butter's fat percentage, often aiming for around 80% butterfat in the final product. In home kitchens, a simpler separation can be done by letting fresh, raw milk sit in the refrigerator for a day or so. The cream rises to the top, forming a thick layer that can be scooped off. While not nearly as efficient as a centrifugal separator, it's a fun demonstration of the principles behind industrial-scale cream separation. Before churning can begin, the extracted cream is pasteurized, a heat treatment that kills pathogens and helps stabilize flavor. Typically, the cream is heated to about 72 to 75 degrees Celsius, or 162 to 167 degrees Fahrenheit for 15 seconds, or a similar time-temperature combination. This short burst of heat eliminates harmful bacteria without overcooking the cream. During pasteurization, operators closely monitor temperature, flow rates, and holding times. Too much heat can alter the cream's flavor, while insufficient pasteurization risks bacterial contamination. Once pasteurized, the cream is quickly cooled, preserving its fresh dairy taste and maintaining the fat's structural integrity. In many small artisan butter operations, you might see a simple plate heat exchanger used for pasteurization. The cream flows between metal plates with hot water on one side, then quickly transitions to a cooling phase. This precise control ensures the cream never develops a cooked taste. Some factories immediately churn pasteurized cream, producing a mild-tasting sweet cream butter. Others age the cream at lower temperatures, often for up to 12 to 24 hours, in a process called ripening. Ripening allows controlled bacterial cultures or natural flora to develop subtle flavor compounds, resulting in cultured butter known for its tangy, complex profile. Cultured butter is popular in certain regions, especially in Europe. Whether sweet cream or cultured, the next major step is the mechanical transformation from cream to butter, the churning process. A small artisanal creamery might keep ripened cream in a cool cellar for a slightly longer period, checking the pH daily. This process can produce butter with a nuanced flavor that connoisseurs compare to fine cheese, highlighting the harmony between controlled microbial activity and dairy science. Churning breaks cream's emulsion, forcing fat globules to coalesce into solid butter while expelling a liquid known as buttermilk. In traditional methods, this was done in barrels or small churns. In modern factories, high-capacity continuous butter churns take over. These machines can process thousands of liters of cream per hour. Here's how it typically works. Cream entry, pasteurized, and possibly ripened, cream enters the churn at a controlled temperature, often around 8 to 13 degrees Celsius, or 46 to 55 degrees Fahrenheit. Initial agitation. Aggressive mixing disrupts the emulsion, causing fat clusters to form. Buttermilk. Separation. As fat clusters enlarge, liquid buttermilk drains away and is collected for other uses. Washing. The emerging butter mass might be washed with chilled water to remove residual buttermilk, enhancing flavor and shelf life. Kneading. Large paddles or augers knead and fold the butter, ensuring a uniform texture and consistency. Continuous churns operate in a steady flow. Cream enters one end and finished butter emerges from the other in a near constant stream. In a home setting, you might replicate this on a smaller scale by pouring cream into a sealed jar and shaking it vigorously. After several minutes, lumps of butter and watery buttermilk will separate. Although it's less automated, the basic chemical change mirrors what happens in an industrial butter churn. Depending on the product, salt may be added during or after churning. Salt enhances flavor, acts as a preservative, and can provide a firmer texture. Some brands also include natural colorants, like annatto, to standardize the butter's yellow hue, especially if seasonal variations in cow feed cause color fluctuations. Factories measure salt levels precisely, usually between 1 and 2%, though this varies by brand and regional preferences. Unsalted butter simply skips this step. For sweet cream butter, no other flavors or cultures are added at this stage, maintaining a clean, creamy taste. Think of a high-end French butter known for its light salted profile. The manufacturer might use carefully sourced sea salt from a specific region, creating a unique balance that pastry chefs prize. That salt not only brightens the butter's flavor, but also provides just enough preservative power. At this point, the butter is nearly finished. However, it still needs careful manipulation to achieve an even distribution of moisture and salt. Large mechanical mixers or augers fold the butter mess, ensuring any leftover buttermilk or water droplets disperse uniformly, preventing weeping or pockets of liquid. Operators also check moisture content. Legal definitions in many countries cap moisture at around 16% for butter labeled as such. Precision is key. Exceeding that limit can classify the product differently, while too little moisture can affect profitability and texture. In some factories, sophisticated sensors measure moisture in real time. If the butter is even slightly above the legal moisture threshold, the line operator makes quick adjustments, perhaps by slowing the churn or tweaking the wash cycle, before packaging proceeds. Continuous sampling occurs throughout production. Technicians measure butter's fat content, salt level, pH, and moisture. Microbiological tests check for bacteria like Listeria or yeast and mold that could affect shelf life. Flavor panels may taste random batches, ensuring no off notes or rancidity. High standards are crucial when producing tons of butter daily. Any unnoticed contamination or quality deviation could impact massive quantities and damage the brand's reputation. Therefore, robust hazard analysis and critical control points, or HACCP systems, are in place at every stage. Picture a lab technician collecting tiny scoops of butter every hour from a production line running around the clock. Each sample is placed in sterile containers, which are then incubated to check for microbial growth. If any sign of contamination appears, that entire batch is flagged, and an investigation begins immediately to trace the root cause. Butter leaves the churn and kneading areas in a continuous flow, heading to packaging lines. There, machines portion it into blocks, tubs, or even decorative shapes. The packaging format depends on the final retail or food service application. For consumer butter sticks, a continuous extrusion pushes the butter through a shaping nozzle, forming a rectangular bar. Rotary knives slice the bar into standardized weights, and automated wrappers swiftly encase each stick, printing dates, brand logos, and nutritional info. Large-scale food service butter might be molded into multi-pound blocks or placed in large tubs. Industrial customers may receive butter in 25-kilogram boxes or even totes for further processing. Some specialty producers, aiming for a gourmet look, use custom molds shaped like flowers or regional symbols. These unique shapes can command a premium price on store shelves, catering to consumers who want an artisanal touch. Packaged butter typically moves into cold storage. Refrigeration stabilizes flavor and texture while extending shelf life. Some factories maintain meticulously controlled temperatures around 2 to 4 degrees Celsius or 35 to 39 degrees Fahrenheit. If butter is needed for extended storage or global shipping, freezing at about minus 18 degrees Celsius or 0 degrees Fahrenheit preserves quality for many months. Distribution networks move butter to grocery stores, restaurants, bakeries, and export destinations worldwide. Trucks with refrigerated compartments maintain the cold chain, ensuring the product arrives in prime condition. Picture a distribution center that handles butter shipments from multiple factories. Workers in cold storage suits operate specialized forklifts, moving pallets from a temperature-controlled warehouse directly into refrigerated trucks. This seamless process prevents temperature fluctuations that could cause the butter to soften or lose quality before it reaches store shelves. Beyond traditional blocks, factories produce a range of specialty butters. One example is Spreadable butter, which incorporates a small amount of vegetable oil or manipulates fat crystal structures to remain soft at refrigeration temperatures. Another is European style, or high-fat butter, with an 82 to 85% butterfat content, preferred by pastry chefs for its enhanced richness. Some brands also churn out flavored butters, adding herbs, garlic, honey, or fruit essences. These blends require additional mixing steps to evenly distribute flavors. Despite the variety, the core process remains: churning cream, draining buttermilk, kneading, and precise moisture control. A gourmet restaurant might serve homemade herb butter as a signature condiment. They start with a high-fat European-style butter, fold in chopped rosemary, thyme, and a pinch of garlic, then roll it into logs for easy slicing. This personalized touch elevates the dining experience and shows how specialty butters can add a premium feel to meals. Butter factories strive to optimize efficiency and sustainability. Upgrading equipment reduces energy usage, while water-saving measures lower environmental impact. Automated sensors and AI-driven analytics track production data, identifying bottlenecks, minimizing downtime, and maintaining consistency. Robotics help with packaging, palletizing, and even cleaning certain equipment. Research and development teams test new cultures, salt blends, or fat ratios to meet evolving consumer tastes. Some producers emphasize grass-fed or organic dairies, reflecting market demand for transparent, ethical sourcing. Imagine a butter factory that implements solar panels on its roof and harnesses energy to power parts of the churning process. Meanwhile, data analytics software monitors the line speed, predicting when maintenance is needed. As a result, the factory reduces its carbon footprint and avoids disruptive breakdowns, ensuring steady production for customers. In an age of informed consumers, traceability is crucial. Many factories log each batch with detailed records on raw milk origins, pasteurization conditions, and final testing results. Certification programs like ISO standards or BRC demonstrate compliance with top-tier food safety guidelines. If a concern arises, for example an off flavor or microbial detection, factories can isolate the affected lot, stopping distribution to maintain consumer confidence. This robust system ensures product integrity for billions of butter servings worldwide. A factory might use barcodes or QR codes on each pallet of butter. Scanning the code reveals the exact farm that supplied the milk, the pasteurization temperature used, and every quality test performed. If any issues are discovered, the factory swiftly identifies which batches to hold back, reinforcing consumer trust in the brand. Butter factories often supply not just retail consumers, but also large food processors. Bakeries, confectioneries, and ready meal producers rely on consistent butter quality for their recipes. Many factories thus form partnerships with these industrial clients, customizing butter in large blocks or specialized formats to streamline the client's production lines. Consistency in color, flavor, salt, and melting point is crucial for commercial users. Even subtle variations can affect baked goods or sauces, so factories maintain strict uniformity across huge production volumes. A commercial cookie manufacturer may request 50-pound blocks of butter with a very specific fat-to-moisture ratio. Their cookie dough needs to spread at a particular rate in the oven, and a slight difference in butter consistency could yield over or under-baked products. By working closely with the factory, they ensure every batch meets the same delicious standard. Butter is a staple around the globe, but preferences can vary. Some regions crave salted butter, while others lean heavily toward unsalted for cooking. Certain cuisines prefer the deeper taste of cultured butter. Factories cater to these nuances with separate production lines or flexible recipes. Exports must also meet each country's regulations regarding dairy additives, fat content, and labeling. Global phenomena like surges in low-carb or keto diets can boost butter demand. Factories adapt by expanding capacity, refining supply chains, and sometimes pioneering niche grass-fed, organic, or premium lines, capitalizing on shifting consumer trends. In France, a bakery might exclusively use cultured, lightly salted butter for its croissants, believing it imparts a signature aroma and flakiness. Meanwhile, a cafe in Japan might import premium European butter to distinguish its pastries, acknowledging local consumers' taste for high-quality international products. As concerns about climate impact grow, many butter brands emphasize environmentally responsible practices. Initiatives range from methane reduction in cows to more sustainable feed, improved manure management, and water conservation. Processors may partner with dairy farms practicing regenerative agriculture, rotating crops, preserving pasture land, and supporting pollinators. Factories also reduce their own footprint. Heat recovery systems reuse energy from pasteurization. Efficient packaging cuts down on materials. Some invest in renewable energy, aiming for carbon-neutral butter production that aligns with consumer ethics. A dairy farm committed to regenerative agriculture might rotate cows onto fresh pasture every day. This improves soil health, reduces erosion, and allows grass to recover. Meanwhile, the butter factory connected to that farm might use biodegradable wrapping paper and drive electric delivery vans. The result is a farm-to-factory system that meets eco-conscious consumer demands. Behind that simple block of butter lies ongoing scientific research. Food technologists study the crystallization of milk fats, dictating butter's hardness or spreadability. Understanding the role of specific fatty acids helps manufacturers tailor melt points. Meanwhile, microencapsulation techniques or flavor science can preserve delicate notes in cultured butter. Biotechnological tools monitor bacterial cultures in real time. Artificial intelligence might predict churn yield or final product moisture, helping factories fine-tune processes on the fly. This interplay of tradition and innovation keeps butter both consistent and dynamic. In a modern lab, researchers might experiment with adding a tiny percentage of exotic probiotic cultures to cream. They track any changes in flavor profile and texture, hoping to create a unique, health-focused butter variant. By combining cutting-edge data analysis with culinary tradition, they can bring new products to market that still feel familiar, yet offer something extra. Even at industrial scales, human sensory evaluations remain pivotal. Random samples from each batch go to a trained tasting panel, verifying that texture, color, aroma, and flavor align with brand standards. They look for possible defects such as rancidity, off smells, graininess, or discoloration. Once the panel approves a batch, it receives final packaging and heads to distribution. Any discrepancy triggers a deeper investigation, ensuring thousands of pounds of butter don't reach consumers if there's a quality issue. A tasting panel may consist of seasoned butter experts who can detect even slight deviations in flavor. Perhaps they notice a faint hint of metallic taste, prompting technicians to double-check pasteurization equipment for any mechanical issues. This real-time feedback loop prevents minor problems from escalating into large-scale recalls. When you unwrap a stick of butter at home, you're unwrapping the culmination of careful dairy farming, meticulous pasteurization, and mechanical churning. Each pat or slice carries the collective effort of farmers, food scientists, machine operators, and logistics experts working in harmony. So, next time you melt butter into a saucepan or spread it on warm bread, remember the journey it took. Consider subscribing for more deep dives into how everyday foods are made, and share your thoughts in the comments. With each creamy bite, you're experiencing a tradition refined by modern technology, transforming humble cream into a golden treasure cherished worldwide. Imagine preparing a homemade bechamel sauce for lasagna. As you add each tablespoon of butter, think of how it was carefully churned, tested, shaped, and delivered to your local store. That awareness can make a simple meal feel more connected to the broader story of our global food supply.